Okay. Did I teach you for the test, or I teach you so you get better at life? And be a better citizen, parent, whatever you're gonna be. Actually. Good morning, beautiful children of Angel. My goodness, thank you. Was it in the Andrew's class? Yeah. That's right. These kids are super honest people, right? They're honest people. I've never had a cell phone stolen all the time I've been here. If y'all don't steal, if your only reason for not stealing something is because it's old, that is a terrible thing. You saw what? Huh.
It's like a really old Ford truck.
Wow. You know it's Ford?
Yeah, it was Ford.
Look at that.
It was really old, and it was barely.
Oh, crud. Let it go.
It was barely moving too.
It was barely moving? It was actually moving?
Yeah, it was moving. The guy was driving it.
It is a Ford.
Yes, I have had this day multiple days.
Wow. It's pretty impressive.
Yeah, it looks like the first truck.
I had a kid give it to me. First piece of candy I've had all year. And that's the first piece of candy I've had all year long. What month is this? Get class. Can't hand it until you get in class. Let's go. Oh my God. What we got? I'm having bad feelings, man. Bad feelings. Poor Kennedy is having a very difficult time getting in here. I don't know. I mean, what else? Is there another way of saying this? I am unaware. How about that? Yeah, it is. But I mean, I don't know where they are. And I'm not messing around. I'm in it. No. Yeah. Yes, but not too. Okay. Thank you, guys. Yeah, just you can drop your answers in. But I'm going to call on one of you guys to help me out with this one. Here comes Kennedy again. She's trying. Hey, Kennedy, man, you're really having a difficult time getting in class. I'm glad that you made it. Yeah, when we have hot time. When we have hot time, yes. Hawker treatment time when we have the gap after this, you can. We got 10-minute classroom periods too. Say what? We have class that starts in 2 minutes. You leave your phone, you can make it back in 2 minutes. We got it. Can you do that? All right, let's do it. All right. 2 minutes. We got it. I don't want you to miss the do now. Good morning, beautiful, wonderful children. Cortland Hayes. Good morning. There's Clarissa Zagal. Good morning, Zagal. I'm having sad feelings, guys. I'm having sad feelings. This is the last lesson I teach you guys this year. I had sad feelings about this. Well, I mean, Jesus, man, I like doing it.
It's okay. You'll have new next
year. No, I don't have anybody new next year. I have no new students next year. Sometimes. The question was, do I go fishing at River Legacy? Sometimes. Yeah, it's fun.
I saw an aardvark
Oh, you did. Aardvarks are African. You did not see an aardvark.
there.
No, you saw an armadillo.
Same thing.
No, it's not. No, it isn't. You're arguing with the biologist about, it's not saying. They are analogs to one another. Yes, they're analogs. There would be these organisms that were convergent. They're convergent. They're definitely convergent with them, but no, they're not. I like going to Lake Arlington and mineral wells to fish as well. Some of you guys are fisher people.
I've never seen one alive.
Beautiful. I'm sorry? Have I seen them? Yeah, I've got a scar on my arm right here from one. They're toothless. They don't have teeth. No, they're not scary.
You don't think anything is
You don't fear things you understand. All right.
Wait.
Wow, we ought to get together and do that and fish. I'm down with that. I go fishing with my juniors pretty regularly. Okay, so now I need a volunteer. Anybody willing to volunteer on this one? Otherwise, I draft someone. I need to know, have you ever, well, that's time to start. Have you ever had a day you felt physically unbalanced? I'm not talking about emotionally. I'm not talking about anything of those in that nature. Physically unbalanced. So we'll give you guys 15 seconds and then I'll draft somebody. But I'd love to have a volunteer first. Good job, you get it just in time. Okay, Mildred, you're it. Come on, Mike, and tell us, was there? It just meant you felt unbalanced. Physically, you didn't feel well. I mean, if I had to think about unbalanced, I would think that I didn't feel well. Generally, when I feel balanced, I feel well. And so was there a time that you did not feel well?
I think it was in the 6th grade. I had the flu.
Holy crap. Okay, so let me ask you another second question. If so, what felt off balance? Like specifically, you had the flu. So what was it about the flu that didn't make you feel well?
Like what didn't feel right?
Yeah.
My
What
stomach.
part of your body?
My stomach and my head.
So your head, any specific part of your head? So you say your head and you know is your stomach, or you just mean your kind of abdomen? Okay, and it was your, if I could spell abdomen. Okay, so your belly in this case. And then your head. What about your head didn't feel well?
Headaches.
Okay, so you had a headache. Now, a headache is actually usually going to be a vascular problem. So this has something's wrong. You have like blood vessels that hurt. So this would be your vascular system here, a headache. It's not really your brain necessarily hurting as much as just because your brain doesn't have receptors for pain. I could literally cut your head open and play with your brain and it would not hurt you. I mean, it would hurt you, but you would not feel pain. Your brain doesn't have sensory receptors to feel pain. Your belly, I don't know. Let's consider this to be a vascular and this to be gastro. Okay, so this is definitely gastrointestinal. So this would be your digestive system, your gastrodigestive system. You're not feeling well at all. Now, okay, did this affect another portion of your body? So let's think about this for a moment. Choose one of these two. I don't care which. Your abdomen. So we're going to go for your GI tract, your digestive system. Did that affect another part of your body? Because you didn't feel well here. In this case, you're going to say this is your stomach. We'll get down to the organ level. Did your stomach not feeling well? Did that affect another part? Did that cause an effect for another part of your body? Your throat? Okay, so your throat still would be part of your digestive system. Was there another part of your body? Well, I'm sticking with her. She's a volunteer. You're, okay, so because you were vomiting and not getting enough nutrition and couldn't keep water down, then you felt muscle weakness. So she had muscle weakness. And I would argue a lot of you guys have weakness. I mean, I bear witness to you guys every day. I'm sorry you're not the strongest group of kids, except for maybe Palacios over here. You know, she's an athlete, what am I going to say? So what we're going to talk about today is going to be a feedback loop where one thing affects another. Nothing works in isolation. Nothing works in isolation. So there's two words I really want to start with: homeo and stasis. And feedback loops. These are the two terms that we're really going to deal with today, and I'll deal with both of these independently. So I want you to think about there's a negative feedback loop, and I want you guys to avoid, what's that?
A school called me from my nephew, and I had to.
Walk out home, talk to him. Yeah. Negative, I don't want you to think of just being a negative thing, like in this case, minus. I want you to think of how a thermostat works. Think about this. If I set a thermostat, and let's set a temperature over here, and this is going to be temp on this side. I wonder if I can write this. This will be hard to write. Oop, didn't do a very good job. Maybe I can get up here. Writing sideways is very difficult. We're going to say temperature, and it looks like our units are going to be Fahrenheit. And we've got this set right here at 72. And let's say it goes up to 80 degrees, and maybe this is down here at 60 degrees. And this is going to be time. So we're dealing with time here. So this is going to time continuum. If I set the thermostat, and I think all of us are familiar with this, it's 72 degrees. And that's this line right here. So I'll make this will be 72 degrees. 72 degrees Fahrenheit. If my temperature, and this will be temperature, if it goes up, and let's say this is 73, the air conditioner is going to kick on. So the air conditioner is going to turn on. And when it turns on, what's going to happen to my temperature, Cortland? I don't know if I'll run past it to you again. This line is my temperature. My temperature is increasing. My thermostat is set at 72. This dotted line is 72. Once I hit, say this looks like maybe it's 73 degrees. Let's just hypothetically say I hit 73. What is my air conditioner going to do if I have my thermostat set at 72? Yes. Exactly. It's going to turn on. Yeah. Thank you guys in the chat. I saw you too. And then it's going to drop, and it'll continue to run until I hit 71. Once I hit 71, what is the thermostat going to do? Let's say Rodolfo, what's going to happen to my thermostat once I hit 71? I'm sorry. I go to 70. I start at 71. The temperature climbs. It hits 73. It turns on, and then the temperature drops. I hit 71. What's going to happen to the thermostat? What's the air conditioner going to do? Yeah, is it going to turn on or turn off? It's already on. Is it going to turn off, or is it going to continue to go? Yeah, it's going to turn off. And then what's going to happen to the temperature, Julian? What's going to happen to the temperature after the air conditioner turns off? Yeah, exactly. It'll start to increase. And this is going to continue to happen over and over and over and over and over and over and over. So the air conditioner turns on, the air conditioner turns off, the air conditioner turns on, the air conditioner turns off, the air conditioner, turns on and off. You're staying an average of 72, but this is 73 degrees. This is 71 degrees. This is how a thermostat works. This is a negative feedback loop because it's got negatives and positives. It goes two directions. Positive feedback loops are different. So we'll use climate change as an example. So here I have humans. We release CO2. We've got factories. We're releasing carbon dioxide into the air. People are driving around in cars. They're releasing carbon dioxide into the air. People are eating bags of crap. That releases carbon dioxide into the air. These things contribute to the earth, and the earth gets hotter. When the earth gets, so this is an increase. But then if the earth gets hotter, the tundra thaws, forests die, they release methane, hydrates, the oceans warm. They don't take in CO2. So they should be taking in CO2, but they're no longer doing that because these are dying. So what happens? We release CO2 instead of taking it in, earth gets hotter. The earth gets hotter, we kill more forests, we release more CO2, we take in less CO2. We stop CO2 coming in, the earth gets hotter, and it continues, and it continues, and it continues. Also, if sea ice melts, more sea ice melts, the seawater turns darker, it absorbs more light, the earth gets hotter, the earth gets harder, heat melts more ice, the water gets darker, it absorbs more light, more ice melts, and the earth gets hotter. This is our current problem. This is going to cost you more money and more hardship than you probably realize in your lifetime. Your life is going to be more expensive because of this one big problem. And the problem with this is we continue to multiply. Our population is increasing and our behaviors are not changing. And for that reason, this cyclical effect continues. This is a positive feedback loop. It goes one direction. No negatives, all positives, all increases. That's a positive feedback loop. So once you think about it and recognize positive feedback loops are one directional, negative feedback loops are two directional. It's pretty easy. You've got to have input. This basically is going to be going back and forth. Positive feedback loops are not back and forth. Kind of think of it this way. Here I have a positive feedback loop. It's going one direction. Or I go another direction. It doesn't have to be a positive direction. It just means one direction. This is a positive feedback loop. This would be a negative feedback loop. Just like I said, they're cyclical. There's a cycle, and they achieve something called homeostasis. So these are our terms for today. Or let's do, actually, I'll give you the terms in a second. I want to ask, is this positive or negative? I'll let you guys look at it for 30 seconds, and I'll call on one of you. Positive or negative? Nope, we're learning. Positive or negative? And let's see, the person that will go first is going to be Navi. What's up, Navi? Navi, positive or negative? You say negative. Good job. Excellent. Excellent job, Navi. Look at the big brain on Navi. Let's try another one. And you can see that, right? You're going to see that if I get more predators means I'm going to get less prey. But when I get less prey, I'm going to eventually get less predators. And if I get less predators, then I'll get more prey. Once I get more prey, then I'll get more predators. But it does go back and forth. Good job. All right, 30 seconds. I've already got somebody in mind, but if y'all want to drop it in the chat, I'd just be curious. Keep it private if you don't mind. Keep it private if you don't mind. All right, Samira, positive or negative? Oh crap, I just put it up there. Crap, I went too fast. Oh, and I'm getting laughed at by going, hey, Lopez, don't laugh at me. You're hurting my feelings. You're hurting my feelings. A 14-year-old can't hurt my feelings. Or are you 15? You're 15. Okay, a 15 hurt a 46-year-old man's feelings. I'm 3 times your age. I'm 300% older than you. Yet she's 15. No, I'm 47. Did I say 60? If I did, I'm insane. Then I would be 400% older than her. It is a negative feedback loop. And the thing, there's a couple of things, and several of you guys put in there. a couple of things here. So you can see an increase. So I get an input. So if I eat sugar, this would be me eating candy. And Lopez did give me a piece of candy. My pancreas is going to release insulin. Insulin takes glucose and puts it into glycogen. Glucose in your bloodstream is terrible for you. This is why people have diabetes. I don't know. Does anybody have diabetes in their family? A family member? Drop it in the chat. I'm just curious. If you do, drop a Y for a yes. If you have any family members that have diabetes, I've got 1, 2, 3, 4, 5. Geez, that's a lot. 6. So 6 of you guys do. So 7. Oh my God. So that's 25% of the class. And this is like one of the things that people call silent killers. It is a real issue with people. So if you eat too much sugar, you get too much in your, and this is an organ, right? This pancreas is an organ. Think of this organ as like having have an expiration date. If you use something a lot, what happens to things that you use a lot? I'm sorry? If you use something a lot, what happens to it eventually? It wears out. That's right. It breaks. It breaks. So if you use something a lot, it will break. It will eventually wear out. It will break down. It has a limited amount of life in it. So you shouldn't be eating a lot of sugar, but if you do, you produce a ton of insulin. If you produce a lot of insulin, you've got to get that blood sugar turned into glycogen. You've got to take this and turn it into this. If you do that, you stay balanced. That's homeostasis. This is no deviation. This is homeostasis. You stay balanced. Homeostasis. If you stay balanced, you stay alive. You don't stay balanced, you don't stay alive, you die. If your glucose decreases, the pancreas is going to receive a message. It'll produce something called glucagon. Glucagon will release glycogen from the liver. You turn it into glucose, and your glucose levels stabilize. You got to have enough energy in your blood to stay with work. So yes, this is negative. This one. 30 seconds. Ooh, good Lord. You guys are killing it. Awesome, awesome. You guys keep it up. I'm still going to call on somebody, but they've already had 11 of you guys get this one right. Good JOB. Eager Beavers. Man, 13, 14% of you guys got this one 100% right. I'm telling you, today's a relatively easy lesson. We got to get this part down. Peyton, is this positive or negative? I'm feeling very isolated. I'd love to hear your voice. Peyton, oh, you're just going to text it to me and hurt my feelings again? You and Lopez have this in common? Hurt my feelings. Oh, man. Thank you. That's what I needed. Hurtful kid. Yeah, it's going to be positive. Again, if you have success, if you do something, you're successful, it increases your motivation. If you have some motivation, you tend to be more successful. The more successful you are, the more motivation you have. The more motivation you have, the more successful you are. And it keeps going and going and going and going. Excellent job. Positive or negative? 30 seconds. And I think I only have 2 more of these before we move into a. Oh, yeah, drop them in there. I'm still going to call on somebody in particular. Your chances of being called increase when you don't drop something in the chat. Positive or negative? Let's see. Let's get. I haven't heard from this child. All right, Zion, is this positive or negative?
Is it negative?
Oh, is it? You're asking me. At least you talked to me. Oh, me more. Oh, I love you. Yeah, it is negative, sweetheart. Good job. This one's a little more difficult, right? So if your body gets hot, you exceed 37 degrees, your nerves are going to detect, right? They're going to get this signal. There's a signal here that is going to be received. There's just like this reception of the signal. So I'll put that out here. There's a receptor. There's this receptor. Oh my God. There's a receptor here. There's something that receives this message. And then that receptor sends the signal. So this signal is sent. So these nerve cells are going to pick up the signal and they're going to send a signal, right? Signal the brain. The brain is then going to have a response. And that response is going to be tell the sweat glands to sweat. They're going to say, you need to start sweating. You need to start sweating. And if you sweat, you're going to cool back off. So your temperature is going to decrease. As a result of that, you're going to get that decrease in temperature. So you start doing something, your temperature increases. You're going to receive that signal. Oh my God, I'm hot. You send that signal to your brain. Your brain sends that signal. It says you need to do something about this. They secrete a hormone. That hormone says you need to sweat, and then your temperature is going to go down. Pretty good. All right. Childbirth, positive or negative? Childbirth, positive or negative? Thank you. Thank you. I've got 2 so far. Let me see who's going to be the. Thank you, Palacios. Thank you, Woodley. Thank you, Mildred. God, okay, I can't keep up with y'all. Oh, and I've got lots of different answers, which makes me super happy. All right, let's go to Williams. Williams, do you think it's positive or negative? Hey, somebody said Williams. You say positive. Ooh, look at you. Could you tell me why? I don't know if your mic's working very well. Could you come on and tell us why you think it's positive? What?
I said it was positive because eventually the baby's going to be like pushed out. So it won't be like a repeating cycle, but I don't really know.
Okay, well, you've got thoughts, and this is what's important. More again. Okay, so this one's actually going to be positive, but it's positive for a different reason. So let's just start at number 1. So here's the baby's head. This structure right here is the cervix. This is a cervix. And a cervix is really what a cervix is a barrier. This is the vagina here. This is the vaginal canal. And what happens is you've got this, and this does 2 things. The cervix does really 2 things. It prevents bacteria. You don't want bacteria, so it's going to block bacteria from getting into the uterus. This is where the fetus develops. The bacteria are blocked, but it also is going to keep the fetus inside of the uterus, which you don't want bacteria getting in there either. So it's going to block bacteria, but it's also going to keep a fetus in the uterus. And the uterus is where the fetus develops. And you want to block bacteria from getting in there because you don't want the female to get pregnant. I mean, no, excuse me, not pregnant, but infected, but you also don't want those bacteria attacking the fetus. So it's like a little barrier. But when the head of the fetus presses against the cervix, this is a painful experience. What happens is then a nerve, this will be step 1. So there's going to be some pain. There's pain. That nerve is going to from there is going to transmit that to the brain. So then we're going to go to the brain. This is step number 2. This is the nerve signaling. This is the brain that is going to then say, oh, so you got pain in your cervix, eh? Well, you need to secrete something called oxytocin. Oxytocin does 2 things. It's often called the love hormone. The love hormone. Or a bonding hormone. It's also called a bonding hormone. If there are multiple females living in a home, often mothers and daughters will have the same menstrual cycle because they have a bonding experience. They love each other and they cycle because of the oxytocin. This is a super strong hormone. This is why you think you're in love when you meet somebody for the first 6 months. These oxytocin levels increase and you go, oh my God, I'm in love. But oxytocin also does something else. It also causes contractions. It will also cause contractions. And a contraction is a muscle squeezing. So it'll cause a contraction so the muscles start to squeeze. So that oxytocin is released into the blood. And this goes into the bloodstream. And then that blood gets to the uterus. Here's the uterine contractions. And then you push again on the cervix. You push on the cervix, you get more pain. You get more pain, you get more nerve impulses. You get more nerve impulses, you get more oxytocin. You get more oxytocin, the bloodstream picks up the oxytocin. You get more contractions, that's going to be squeezing inward. This is the uterine wall, this thing right here is going to squeeze inward. When it squeezes inward, it's going to push the fetus against the cervix. It's going to cause more pain, more nerves, more oxytocin, it gets in the blood, more contractions. Eventually, the fetus does come out. This is a positive feedback loop. You can see nothing but positive symbols all the way around. Pretty cool. Last one. So you want to keep that phone? You might want to put it somewhere I don't see you use it. Good idea. All right, let's see. What do you think? Lauren, how long have you been in class? Okay, so you don't know what a negative feedback loop is yet? Okay, so I'm not going to call you. All right, let's see who the next contestant is on the Pope is Right. I'll jump to the most beautiful child in the room, not psych, whatever. Let's say, I've already looked at this list pretty well. Yeah, let's go to Clarissa. Clarissa, positive or negative? Zagal. You got all this gall, Zagal. What do you think, kiddo? Positive or negative? Ooh, look at Clarissa, the big brain on Clarissa. Could you come on your mic and tell us why? She said negative.
Oh,
Why?
I put negative because I saw that there's stress and also that the blood pressure was being decreased.
Okay, so still, stress may be a bad thing. I don't want you to think that this is bad. Negative does not mean malo or bad. It doesn't. It's my Spanish speaking skills. I'm terrible, right? Matter of fact, hold on a second, Clarissa. I'm going to back up for a second. I want you to remember this about feedback loops. Negative feedback loops go for balance. There's going to be increases and decreases, increases, decreases, increases, decreases, but you stay relatively balanced. Positive feedback loops go one direction only. So let's go. So do you see any increases or decreases here? Anything that tells you an increase or decrease? Because all stress is what we call an induction. Induction is to start. And this would be starting. This is the starting point. So this is an induction, I'm starting. Do you see anything that shows increases? Because I got to turn this over to you guys in a second. Y'all got an assignment. You're not here just to watch this. I really want to make sure you guys understand this.
The blood pressure increased.
Yeah, the blood pressure in this case decreases and then it eventually increases. And here you can see it's going to increase because here's the loop and then it's going to decrease. All right, so blood pressure increases. So here's my blood pressure increases. And then here's my receptors. Look for that receptor, right? So this is my kind of like something happens. So this is like the event, right? I've got a stress, that stress increases my blood pressure. I get that signal, that receptors detect that change. And then my response, here's the response, I'm going to increase the diameter of my blood vessels. So this is my response. So I get a receptor and I get a response. So if my blood vessels are narrow, let's pretend this is my blood vessel. If I've got a high pressure, all I gotta do is open it up, make it larger, and that decreases the pressure. It's kind of like a balloon. If I have a balloon and I make it bigger, I just expand it. I don't change how much air is in it. The pressure is gonna go down. Same thing here. Some people respond differently to stress. We've both had a stressful year. Some people's blood pressure goes up and they act crazy and they're, my blood pressure's high. This is me. This is how I react. Some people go the other way. My blood pressure gets low. I get sad. I don't feel great. So your body says, oh my God, I just decrease my blood vessels. So if your blood vessels are wide, well, then I squeeze that blood down a narrow tube. I literally squeeze it in and my blood pressure rises. And I get back to normal. Got to get back to normal because both of these are not a good place to be. So these are terms that you're going to use today. And again, I've made this PowerPoint available and I'll come back and I'll show you where it is. Homeostasis, another way of saying that is just being balanced. Stimulus, a stimuli, that's going to be like something happens. In this case, this was the stress. Something happened. The response is going to be this action that I take. In this case, my blood vessels change diameter. They change the diameter and I get better. I'm going to run out of space. Feedback mechanism loops. This is the loop itself. Is it going to be, a positive or negative? It's not too hard. So let's look at one and then I'll cut you guys loose. Stimulus occurs. So something happens. So it could be cold. It could be pain. It could be a light touch. It could be heat. You could have a movement of a hair. All these things are going to be a stimulus. You got different nerves in your skin that do detect different things. Like this strong pressure is deep down in your skin. They only detect strong pressure, but you're going to have a receptor that detects that stimulus. You have to have some way to receive that message. In this case, it's nerves. It's these, what we call sensory neurons. So sensory neuron picks up the signal. Sensory, it could be an audio signal, but this is going to be a nerve that picks up signal. You feel something. This is feeling. So your eyes have sensory neurons, so they detect light. Your ears have sensory neurons. They detect sound. There's lots of different types of sensory neurons, but they're going to receive a message. They are a receptor. But then you've got to send a message, and they're to a control center in this case. So if I send a message, I got to send it somewhere. So if I send a message, this is me, and I want to send it to my grandmother, then I've got to send it through the mail, right? There's got to be some way to get that message there. I like to write my grandmother letters. So if it's me trying to get to her, there's got to be a way to get to my grandmother, the control center, so to speak. How do I do that? Well, there's a couple of ways, and I'll show you what that is. This is an example. And how many of you guys have burned yourself? Anybody burn yourself? Even in here? God bless. You guys need to be careful. 5 of you guys? Jesus Christ. All right, so if you burn yourself, look, okay, so there's 10 people total because 5 more in the chat. What's that, Emma? Ask Emma.
I've burnt myself before.
Oh yeah, yeah. Okay. Me too. I've burned the crap out of myself and my son. Cortland, are you okay? Where's you can't log in? Why not? I can't hear you. Okay, why aren't you? Okay, you're great, not mine. Okay, so motor neuron would carry that message. So you get the pain, I'm gonna receive the message, receptor, and then a motor neuron is gonna carry it. And motors carry things, right? It's like a car. A car, you could think of it like a car. So this is a car. It's gonna carry the message, and then this is gonna be received. So this is gonna be receiving the message. This is like the control center. A control. Control center. And then you gotta have to do something. The question is, what do I do? Well, then I'm going to send that to a muscle. So this is gonna be nervous system. Nervous system picks up the message, but I can't move anything with the nervous system. So I send that to a muscle, to the muscular system to work together. So they work in union, they work together. And this would be what we call a reflex arc. And then the muscle is the effector. It causes the effect. This muscle is the effector. So in this case, this will be muscle. So the things are going to work together. There's always things that work together. So in this case, the nerve is working with the muscle to maintain homeostasis. You maintain homeostasis. They work together. So I receive the message and with nerves in the skin. I interpret that message with the interneuron, still with the nervous system, and this is in the spinal cord. And then I send a message with another neuron. This is a motor neuron. It's going to take an effect. And then I send another neuron to take the message back to my muscle, and it's a loop. This would be a positive feedback loop, but it does end. It does end when I've removed my, my hand from a flame. So let me show you what you guys have got to do. You're not even in class, you're asking me these things. I don't understand. All right, take you guys, make sure you can see this. All right, this is your assignment. Now there's a couple of things about this assignment that you need to take into account. These are the ways that you earn points, and you've got two options today. Either you do it as a group or you do it by yourself. You do have some options. So you're gonna find a feedback loop on the internet, any feedback loop you want. It has to be a biological feedback loop. That's worth 10 points, just the image. And then you have and you identify it. So you give it a title, negative or positive. That's 25 points now. But then there's going to be different parts. There's a stimuli. You identify what's the stimuli, what's going to receive that signal, what's the action taken, what is happening in that response, and then what is this, where's that signal, what is that signal that's received due to that response? And I'll show you what I mean. And then finally outline, like, how is this achieving homeostasis? I've done an example for you. So mine was the birthing, the one that I gave you before. The stimulus, the fetus, it moves into the birth canal. That's pressure on the cervix. You feel the pain. There is a signal that's sent from that cervix. That's going to be that pain, right? The action taken was the oxytocin is released by the hypothalamus. And you can see here, you can literally just follow the cues, follow the lines. I mean, they're going to, hopefully, most of the feedback loops you have are going to have some text for it. You are going to then Tell me about the response. There's that signal. What does that oxytocin do? The oxytocin causes contractions. And then how is this maintain homeostasis? Well, eventually this fetus is going to exit the body. Eventually. So that's what you've got to do. Questions before I put you into groups. Now, before I put you into groups, let me explain one more thing. You're going to see, and can you see this? It switched back to normal. You can see there's submissions by everybody. Everybody can submit. But you don't have to do it if you guys don't finish today, and this is not your class, but if you, let's say Jada, Alexa, and Gio were all in a group, if the people that are working together in that group, they can put their names on the document and submit together. But at the end of class, if you don't submit, then I'm going to see, you're going to have that little message that says, hey, you need to submit this. If you need to submit regardless, or that message is going to stay. But if your name is on another person's document, I will count that as being yours and you don't have to worry about it. So are there any questions before we get started? Questions before we get started? All right. I'm going to drop you guys in those rooms. Get ready to go. You're going to have fairly small breakouts, so there'll be groups of 6. Once you see you can jump to your room. Boom, boom, boom. Yeah, they're not all the rooms are open yet. They're coming. All right, you guys should all have a room now. Oh my God, one of the kids did it this morning before class even started. What the heck? They just saw it, they needed to do it. I would, if I were you guys, I would have one person share screen and work together on that one thing and assign tasks. Somebody should be looking for a loop, Fast and Furious. God. Jennifer, you and it's just you two in the room by yourself? Oh no, would you like to jump in a room with other people? Are y'all okay? Y'all are friends. I put y'all in a group together because I knew you were friends, and so we're gonna test that out, but I thought I put somebody else in there with you. Y'all are okay together? All right. I thought I dropped one more in there. I'll be grading it independently. Hey, what's up? I thought I'd jump in over here. What's up with you guys? I would, if I were, yeah, I would share my screen and work from the same document talking, but if you guys are just taking that document and share it, but the one person who owns that document, whoever's document you have, is gonna have to share the document, if that makes sense. Yeah, I don't know. That's up to you guys. Yep. There's another group calling me. What group are you in? What group number? Well, I'll jump in your room so everybody can hear me. You're not working by yourself. Who? Well, jump in your room. Which group are you in? Which group? 3? All right, I'll be back in a sec. Kiddos. So what was your question, Isosa?
I wanted to ask you if you could.
You don't have to. You pick a reason.
Okay.
Yeah, could you share your document that I'm? Yeah, just share what show me your document. Okay, Peyton just shared it with me. Oh, that's all right. I still would like to see your screen so it might be easier for me. So okay, this is it. So for you, can you go to present so I can see it bigger? They can still change it. So the stimulus is going to be whatever the event is. So let's see, what is this one? Oh, okay. So it could be 2 things. It looks like the body temperature is either, what do you think? The stimulus. Body temperature is what? Or, yeah, it's either one. I mean, it's just the body temperature changing. That's all the stimuli is. Yeah, the stimulus is just the event that caused there to be the need for a change. Like in this case, it was the cervix pushing on the head of the baby's pushing on the cervix. I don't know. There you go. All right, I'm gonna jump back to group 1. Children of Earth. One of you guys, whose document are you guys using?
We're using Zion's.
All right, well here, share it. I want to see what you guys have so far. Oh goodness, this seems to be the common example today. Third one I've seen so far. Okay, so stimuli, body temperature increases, okay, or decreases. There you go. You don't have to necessarily write that much but you can. Because what you've got for stimuli almost captures how it maintains homeostasis at the same time, right? But still, that's a good job. All right, so you guys, and you got everybody on it. So I got Yolanda on it. Who is this? This is Samira. So, and okay, you got everybody. Look at y'all. Love y'all. All right, deuces. Participating people on it. Good job. All right. Good morning, beautiful children of Earth.
Hi.
Hey.
You're under attack.
Hey, share your document with me so I can see what's up.
We haven't gotten to it yet. 'Cause
Okay, all right. Well, what example are you guys thinking about using?
Well, we're still kind of looking for one. We were having some tech issues and like editing and stuff. Like we couldn't get on to.
All right, all right. Yeah, you guys are a little behind the other groups. I'll come back in a minute. Bounce into another one. Hello, beautiful children of Earth. Whose document are you guys using? Huh? I know it. That's what I asked. Whose document are you guys using? You probably, Kennedy, it's probably because you're not logged into your student account. You should be able to edit it. Okay, that's weird. So use somebody else's. So it could be Clarissa, Cortland, or Laura. They could share their document with you. And you guys could use that one document. All right. She just texted you guys. Anybody responding to her? All right, good deal. I'll come back to you and check you guys. You guys got a little, you don't have a whole lot of time to make it up. We only have 19 minutes remaining. All right, whose document are you guys using? Whose document are y'all using? All right, can you share it? Let me take a look. All right, man, this is like the common one today. So out of 6 groups, this is the 4th one of the same feedback loop. I guess this is like if you Google feedback loop, it's probably the first thing that comes up. So let me look. So you see, what is the receptor? So like you need to get there, action taken, signal, da, da, da. You might have to go back to where you got that image. You may have to go back to where you get that image. You got to figure out what is the signal receptor. What is that signal receptor? Like go down to the next, my slide, my example. See my signal? Neurons receive signal in cervix. So you got to figure out what is receiving that signal for that temperature. That's what you've got to figure out. That's what you've got to figure out. All right, but you're on your way. I'm going to go to another group. Right, coming back to you guys. So whose document are you guys using? All right, Alex, share your screen. Let me check it out. No, I'm talking about like share your screen, yo. So I can take a look at it. All right, yeah, go down to the one you're working on. You're the only person on that document. Holy crap. What do you mean, yo? Why don't you guys, what do you mean the thing's still out here? What are you talking about? there's the document. So Alex just put the document in there. You can click on that and then you can add yourself to the doc. I'm just bouncing room to room to room. I'll come back and check on you. Now you guys are on it. Now you guys are on it. All right, I'm gonna jump to the next room. Ooh, I want to see you guys progress now. I'm tripping. See what you got. Signal receptor, forebrain reacts to the temperature fluctuation response. Yeah, but how does that signal get to the brain? How does the brain doesn't detect temperature, something else does? What is receiving that temperature, that receptor? So the signal, the actions taken by, could be the brain, could be the skin, but what is receiving the signal that you are not receiving, picking up the signal, picking up that stimuli? What is picking that up? How does the brain know that there's a change in temperature?
They said something about the hemp something, and I looked it up, and it said it was the forebrain that
Yeah,
reacts.
the fore part of your brain, but how does that message get to the front of your brain? How would you pick up a message to get it to your brain?
Nervous system?
Yeah, well, your brain's, that's a pretty broad thing. Your brain is part of your nervous system. What part of your nervous system receives messages? Like literally from the environment, picks up these messages from the environment. Like my photoreceptors in my eyes receive light and send that to my brain. My brain does something with that information. But my photoreceptors pick up light.
Your skin, because your skin touches it?
Right? And what kind of neuron in the skin will pick up a signal? That's the question. The rest of it looks pretty good, to be honest with you. I think you guys are done once you get that part. I'm sorry? Boom. Roger that. All right, you guys, share your screen again. Let's see where you guys are now. Sosa, you guys finished? Sosa, did you guys finish? Did you guys finish? Show me. Yeah, whomever's document, let's go. Another group thought they had finished, but I need to give them feedback. Okay, so here's the deal. So I'm looking at y'all's. That you got the stimulus. Now it says being cold or hot when you feel what your body temperature is. Okay, what is the receptor for that information? What receives that information? I'm sorry? I don't know. You need to look that up. Okay, well, do you need to, your grade depends on it. So you guys checking each other's stuff, right? Okay, so like I was saying in that letter, right? You know, I did my part, somebody else did their part, but we checked each other's part. So we got each other's back all the time. Shivering or sweating, action taken, okay. So what, okay, so signal received, what part of your body is actually shivering? So signal received, what's receiving that signal? What part of your body is saying shiver? I don't know, man, you better start talking to your group, because right now I'm looking at this, I'm thinking that's an 80, and you could easily be 100. That to do something, yeah. And then what group are you in? Document are you guys using? Clarissa, share your screen so we can check it out, yeah. Man, my head feels like it's gonna pop. So, man, this is the one everybody loves today. Geez, maybe not everybody. Half the kids are using this one. Stimulus, the body temperature determines which other body. Okay, so that's a temperature. Okay, the signal receptor. So, what part of your body, what portion of your body detects that there's a change in the temperature? What part of your body is saying, oh? Well, the brain receives the message. How does it get to your brain? Because my brain can't. Which nerves? Because I've got nerves all over my body. So where would I determine temperature? What part of my body? Well, how do you know if it's hot or cold in this room? What part of your body is coming in contact with the atmosphere? Your skin. So what kind of nerves are in the skin that receive signals? Yep, we just went through the PowerPoint through it with it. You can go back. I've got the PowerPoint on the site. I just went over this. All right, so let me see. Action taken, the mechanism of heating and cooling. Okay, so what is the action taken? What is the action taken? The mechanisms of heating and cooling are being activated. What are those mechanisms? Huh? Yeah, but what are those mechanisms? So what happens? What mechanism that cools you down? What cools you off? Sweating or the shivering if you were too cold. Exactly. You got it. All right, I'm going to jump to another group. We only have, 7 minutes. Know if it's a positive or negative feedback loop. Holy crap. I think you guys are going to get this done. I skipped over this group. Who the hell was that? Okay, yeah, I skipped over this group. Get this. This is not that difficult. All right. What's up, Pizza Head? Holy crap, you guys decided to use insulin, huh? Okay, stimulus, the stimulus is pancreas because it's getting triggered. Okay, what's triggering? Okay, low blood sugar, that's it. Either high or low blood sugar. Okay, receptor, what is the receptor? What is receiving the signal that glucose is too low? What is receiving the signal? Yeah, the pancreas. Now you got it. Pancreas. Now, what is the pancreas doing? Just stimulates glucose uptake from blood. Okay. How is it doing that? I'm sorry? Not blood pressure. This is blood sugar. So what does it release? What does it release? It releases two things, one or two things. If blood sugar is high, what does it release? If blood sugar is low, what does it release? Or glucagon. Yeah. Yep. All right. You guys are on your way. We have 5 minutes. You got it. Boom. You got it. Boom. Oh, let me get over here to bird head looking kid. All right, share it. Let's hurry up. I want to try to see you and one other group one more time. Hurry, hurry, hurry. Let me see. Tripping balls. Oh, my neck. Stimulus, temperature, receptors, nerves. What we say? Okay, which nerves? Which nerves? Which nerves? That's what I'm looking for. Which nerves? Talk to Cortland. He knows. Let's see. Action taken. Responsibility getting. What action do you take to get cooler or hotter? That's what the question would become then. What would be the action that you would take to get cooler or hotter? Okay, and then what is going to actually carry out that signal? So signal received due to response. So what's going to happen? Okay, I think you actually got it, except for those signal receptor and action taken. That's what we're looking for. Those two things. All right. Oh, okay. Share your screen now. Let's see where you guys are. You guys are I think y'all are the only group I haven't seen that hasn't finished. Holy crap. Oh my God, you guys are in trouble. Okay. Looks like you guys are going to be having to do this on your own and send this and submit yours independently. The other groups have finished. I am sorry that you guys weren't able to get it done in the 30-minute time period that we had. Yeah, but you can still submit it by midnight. And here we go.
Why does it keep switching?
What's keep switching? Hey, somebody say ugly. Hey, somebody say ugly. All right. Guys, well, there's still people in the rooms working on it to the last minute. Like, we got to get this done. Oh my God. Oh my God. Everybody's tripping. Hello, beautiful children of Earth. All right, you guys did really well. I think I think 5 of the 6, I know 5 of the 6 of you guys were able to finish. A couple of things to remember. You need to put your group members on the, if there's one person that did it, slide that you shared, which is true, make sure that their names are on there and submit. If you didn't, you have until midnight. This is the last lesson that I'm teaching you guys. I'm feeling very sad. Oh, hush, Mildred, hush. I feel kind of sad for it. There's some of you guys I wish I had gotten to know a lot better. When you guys get to campus next year, please come by room 207 and see me, please. I want to see your faces. For those of you guys I've not actually physically looked at your face. I saw Palacios full face for the first time, even though she's been here last week. Was it this week? And I didn't run. It wasn't that bad. It wasn't that bad. All right, love you guys. You guys be good, man. I love y'all. Wild Kratts. Somebody put on Wild Kratts. I look like Wild Kratts. Man,
He
y'all
does look
shut
like
up.
one of the wild Kratts, okay?
Yeah, people are making fun of me with Wild Kratts and crap. Man, what the heck is that?
We're not
That's
making fun of you by calling you the wild Kratts.
what?
We're actually complimenting you.
Oh,
because-
is it? Okay. I mean, I don't know. The little cartoon characters on television. Do I look like a... Yeah, okay.
Well, you look like the human ones, but
Okay, I look like the human one version of it. Okay, great. All right, you guys
Yeah,
be
like, you
good.
would be on Zaboomafoo. Zaboomafoo.
I don't know what that is.
It's an animal show.
Oh, yeah. Well, I am an animal. I don't need to turn into an animal. I'm already an animal.
No. It's where we talk. They talk to us about different animals and stuff.
I have ancillarily seen the Wildcrats on television before. I've never directly watched it, right? You know, but I'll just watch it.
Like, this is
Yeah.
the funny thing about the Wildcrats is like, even though it's meant for kids, like quote unquote, it's meant for kids. I could still watch it any day of the week because it is it's still.
Well, you're a kid.
It is meant for children under the age of 8, but
Oh,
I'm
it says
saying
8
for
years
my
old.
demographic, it's still good.
Okay. Okay, Emma.
Okay, you're crazy.
You guys be good.
I'll run in the street.
Run in the street. That's the way to do it.